3.3, logarithmic functions and their graphs. We're not really doing the graphing part, just the solving the logarithms, just because you can mainly do that on your calculator. So we're going to jump right into solving logarithmic equations. So number 2, I have log base 6 of 1, and I want to know what that is equal to. So in your notes, you should have had some properties of logs. So what does a log base whatever of 1 equal? Yep, 0. Now, if you say forgot the property, then we can do my little trick that I do of making the e. We start down here. We put a random, like a variable there to solve for, and we would say 6 raised to what power is equal to 1, and we would know that that would have to be 0. So that's like another way you can do it if you didn't remember the properties. Number 4 is log base 3 of 81. Oh my goodness. I'm gonna fight it. Okay. So anytime I have something like this, I want to see if I can rewrite something to be able to solve it. So is there a way that I can rewrite 81 in terms of 3? What is it? Okay, yes, that is true, but like 3 to a power.
Oh.
3 to the 4th, so I would rewrite this as log base 3 of 3 to the 4th, and you have a property that tells you that that's equal to what? 4. Six. Log base 6 of 1 over the 5th root of 36. So if you can rewrite stuff, that's kind of the easiest way to think about them, especially with one that's really weird like this. So if I wanted to get rid of this radical on the bottom, what would I do? Like, ignore the log base 6. If I just wanted to get that with the radical on top, how would I do that? Like, how would I rewrite this?
Like multiply it on top and bottom. Rationalize.
Okay, I mean like rewrite it in terms of exponents.
Power of 5.
5 root 3, 6. Wait. Negative 1 to negative 1.
Okay, ignore the fact that it's on the bottom. How would I rewrite a 5th root of a number? Raised to a power.
Fraction.
So this right now, let me just go over here for a second. 1 over the 5th root of 36 could be rewritten as 1 over 36 to the 1/5. Okay, I want that on top though. How would I rewrite that?
36 to the
Okay, 36 to the negative 1/5. Now, I have a base 6. Can I rewrite 36 as a base 6?
Yeah.
As what? Okay, so this would be 6 squared raised to the negative 1/5. Or I can bring this over here and write this as log base 6 of 6 to the negative 2/5. So what is this equal to?
-2/5.
Yep, negative 2/5. Eight, log of 10,000. So it's not written here what base is on this log. Log base 10. So can I rewrite 10,000 as 10 to some power? And if so, what would it be? Think about how many zeros there are. What's 10 times 10?
100.
What's 100 times 10? What's 1,000 times 10? How many times do we multiply 10 together? 4. So this would be log of 10 to the 4th. Log base 10 of 10 to the 4th would be equal to 4. Log of 10 to the negative 4. What will this be equal to? Negative 4. (14) ln of e to the negative 4. What does ln mean?
Log of the base of e.
Yep, log base e, so this is just like the ones we've been doing, so what would this one be equal to? I know Tristan knows. Let's see. 16. ln of 1. What would that be equal to? 0. 18. ln of 1 over the square root of e to the 7th. So I need to rewrite this one. How can I rewrite this 1 over the square root of e to the 7th?
E. Wait, square root of 1/2.
So ln of 1 over e to the 7 halves, and then what?
E -7.
Yep, so ln of e to the negative 7 halves, and you can go straight here from the beginning if you recognize that. So what is this equal to?
-7/2.
-7/2. All right, any questions on those kind? That's why it's critical to know those properties that are in your notes. 20. 5 to the log base 5 of 8. So this is another property. It's property 4 in your notes. So the 5 raised to the log base 5, those things cancel, and we would be left with 8. So this would be equal to 8. (22) 10 to the log of 14. What would this one be? 14. 24. E to the ln of 1/5. 1/5. All right, any questions on those? All right. Next stuff in here says to use a calculator to evaluate the logarithmic expression if it is defined. And then it says to check by evaluating, which we probably won't do that, but you are welcome to check that. So something to note here is that, I don't know if this was in your notes or not, but we can't have a negative or 0 inside, I cannot spell, inside the log. If we do, it is undefined. So your calculator, if you type in the log of a negative number, it's going to come up and say either like syntax error, domain error, something like that. And that's going to pretty much be your clue that it was undefined. So, (26) is log of 0.908. So yesterday we talked about where to find log base on your calculator in case you had forgotten. But if I have one like this is a common log base 10. That's what this log button that's actually shown on your calculator here is for. So you just hit log and then type in the number. And you get out a negative 0.0. Does it tell me how many decimal places to go to? It does not. Let's just say 3 decimal places. So negative 0.042. So the way that we would check our answer here, just so that you can see it, I'm not going to require that you do it, but if you wanted to verify that your answer is right, which, I mean, hopefully your calculator gives you a right answer, would be this is base 10. So I could go loop around here. 10 raised to the negative 0.042. And if I type that in my calculator, so 10 raised to the negative 0.042, I get 0.9078, which would round up, oh, you can see that, to 0.908 there. So that would be showing you that your answer is correct. Okay. So if you wanted to check it, you can. 28. Log of negative 5.14. What is this?
Undefined.
Why?
It's negative.
Yep. This one is undefined because we have the negative inside. 30. ln of 0.733. So with this one, this is a natural log. You have an ln button over here underneath log. So just hit ln and then put the number in. And I got negative 0.311. And again, you could check it if you wanted to. All right, the last stuff in this section is to solve the equation by changing it to an exponential form. So 34, we have log of x equals 4, and we're trying to solve for x. So I do that with the E method. So you start down here, up through the 4, and back down. So going from log to exponential, we make an e, and that's how we solve it. If we go from exponential to log, which is what we were doing at the end yesterday, then we make the L. So this is a log base 10, so 10 raised to the power of 4 equals x. And what is 10 to the 4th? 10,000 equals x. (36) log of x equals -3. So same thing, loop around. So this is 10 to the -3 equals x. What is 10 to the -3?
One over 1,000.
Yep, 1/1000. And if you wanted to write it as a decimal, it would just be 0.001. So either way would be totally fine for you to write your answer. So that's all that's in this section. The big stuff is you just got to make sure you know your properties and are able to rewrite things in terms of exponents. So your problems are 1 through 25 odd, 29, 33, and 35.